Okay, I'll walk through a solution to the introductory exercise on using distance, which uses the DuckNest project. So the first thing we ask you to do is open the project. So if I choose File, Open Project, by default it's looking in a directory My Distance Projects, and I saved all of the exercises for this workshop in a subfolder called Exercises. There it is. And I need to choose files of type zip. Oops, files of type zip. And I'm looking for DuckNest exercise. There it is, .zip. Now if I click open, it's going to ask me which directory it wants me to unpack that zip file into. And I'm fine to unpack it into the suggested exercises folder, so I'll click OK. And there it is unpacked and the distance project is opened. And it's opened in the Data tab here. So this is the Data Explorer, and I can see the 4 data layers on the left hand side here. If I click on the observation layer, it opens up all of the data layers here, and you can see there's the study area layer, which is the global layer. There's a stratum layer called region, a sample layer called line transect, and an observation layer called observation. And you can see the fields in each of these layers, and you can see the records here. So if I just go down, for example, in the transect layer, if I just zoom down to the bottom, here we are, I can see that there are 20 transects. I can see, if I go down to the bottom again, there are 534 observations. And just as an example, the first transect, if I go down a little bit, there we go, it's got 27 observations in it. And then here are the distances. If I hover over some of these headers here, for example, I can see the units are in meters, field type is decimal, the field name is perpendicular distance, or perp distance. Okay, so that's how data are laid out in distance, and we asked you to play with that a little bit. The next thing to look at is running our first analysis, so I'll click on the Analysis tab here. And this is the analysis browser. There's one line in here per analysis, and there's only one analysis that's been set up so far, so here it is. And what I'm going to do, if I just move this out of the way here, move this slider bar to the right. There we are. You can see that there are some columns here on the left hand side of that bar and some columns on the right, and the columns on the left are things that tell you about the analysis before it's run, and the things on the right are summary statistics about an analysis after it's been run. So for example, here I can see that the name of this is half normal with no adjustments, and it was created all the way back in 2008. It hasn't been run yet, and I can tell it hasn't been run yet because this is the status button, and the status is grey, which means not run. After I've run this thing, that status will turn green. How do I run an analysis? Well, there's lots of ways I can do that. One of them is that I can use the drop down here, Analyses, and I can click on Run Analysis. Another is I can click this little running man here, which will run the selected analyses in the analysis browser. I can also do it by opening Analysis Details and clicking on the Run button. But what I'm going to do at the moment is just click this Run button here. And you should see this thing go green. There we go, it's gone green now, and some summary results have been filled in on the right hand side. For example, I can see that the estimated density is 49.697, which hopefully is quite close to the value that you guys got when you did it by hand. So I want to look at more details for this analysis now, and one way I can do that is, so I want to open a window called Analysis Details. So I can do Analyses, Analysis Details, or I can click on the Analysis Details little magnifying glass here, or I can double click on the status button. I'll just do that, and it opens up this window here, which is the Analysis Details window. And the Analysis Details window has 3 tabs down the right hand side. Inputs, so what you specified for the analysis, a log that records what happens when it ran, and the results. And because this analysis is green, it ran with no problem. This is coded green and it opens the results by default. If you had any problems, then this log tab will be coded orange or red, and it'll open that by default. And if you haven't run your analysis yet, it'll open the Inputs tab by default. There's a little comments window down at the bottom here where you can type in comments about the analysis. This is a great analysis, for example. And those will be there next time you open the window. So for example, you could record, this is the analysis I used in my paper or something like that. Let me just drag that down out of the way so we've got more room to see this screen here, and I'll drag this to the right as well. There we go. So the results are displayed in a series of pages, and we can use a drop down here to look at all those pages. And we can also use the next and the back buttons to page through them. And this first page just gives you a summary of what you specified in the first place. So how you wanted the analysis to be done. It's just telling you that back again. So for example, I can see under estimators here, I wanted a half normal key with no adjustments, etc., etc. So if I go to the next page, this is a page about model fitting. It tells me the survey effort, the number of transects, the truncation width, and the number of observations. And then this tells me about the detection function model fitting. So this is the model that I fit, a half normal key. This gives me a formula for it. Oh, that reminds me, if I just go back one and look at the bottom, there's a glossary here of all the symbols that are used in these results pages, which is very useful. Sorry, I forgot to tell you that. Okay, so a half normal key here, there's the formula. There's one parameter, this A1, which is the scale parameter of the half normal. It was given some bounds to start with. The analysis converged. There's some likelihood and other statistics about the fit. And here's the final parameter value, 2.54, that maximized the likelihood. The next page gives me sort of a summary of that information. So there's that 2.54 again. And it gives me the estimated P sub A, probability of detection, and also the F0 and effective strip width. And as we found out earlier, those are just expressions of the same thing, just expressed different ways. So the estimated probability of detection between 0 and 2.4 is 0.869. It gives me also some information about the uncertainty on the estimate. If I go to the next page, this is a QQ plot, so this is a measure of goodness of fit. We're going to talk about those in a subsequent lecture. And here's a numerical summary of goodness of fit. And this is a detection function plotted over a histogram of the data to let you evaluate how good the fit is. And following that is a chi-squared goodness of fit test. Again, we're going to talk about goodness of fit testing later on. If I just go back one, I can see that this does look like a very good fit. And indeed the chi-squared there, a p-value of 0.461, so this is testing the null hypothesis that the data could have been created by that model, and we failed to reject that null hypothesis. So a non-significant p-value here tells you something like it's a reasonable fit to the data, which confirms what I can see by looking at it. Then there's a page of density estimates. So this is my density estimate, 49.697 with estimates of uncertainty. Then a summary of the whole analysis. So this is encounter rate, the number of animals that I saw, or in this case nests that I saw per unit line length. Again, a summary of the detection probability. I'm afraid there's some repetition here. And then a final summary of the overall density. And there would be a summary of abundance, but I don't have abundance here. Why don't I have abundance? If I close this and go back to the data, and I look at the area of the study region, so there's only one region here. If I just go down to the bottom, you can see that there's only one region, all the way down to the bottom. The area is 0. So when you don't know the size of your study area, in this case this is historical data and we don't have that, then if you put the area 0, then distance will give you a density estimate, but no abundance estimate. Okay, that's all I want to say about this project for now.